All right, so for a little extra practice, we're going to translate these situations and write these into equations. And we're not going to solve them now, but we'll just set them up using systems. First one, there are 12 more scientific calculators in Mr. Mathman's classroom during first hour than there are graphing calculators. So let's go there. I'm going to let scientific calculators be one variable and graphing calculators be the other. Now, it makes sense to use G for graphing calculators, and it makes sense to use S for scientific calculators. The problem is whenever I use S's, sometimes they look like 5s. So I try to avoid S's. So I guess I'll just call that, I don't know, I'll just call it X. So let's use our let statements. Let X equal scientific calculator. And let's let G be the graphing calculators. And if it's noisy in the background, I apologize because it's at the end of the day of school right now. And let's just do 12 more scientific than graphing. So if I tried this, you might want to think there's 12 plus the scientific because it says 12 more scientific. The thing is, if I make that equal to G, if I say my answer is, say there's 5 graphing calculators and there's 12 more scientific calculators, that means there's 17 scientific and there are 5 graphing. Well, if I look up here, if I plug 5 in for, is that a G? 5 in for G and 17 in for the scientific, it doesn't work. So you actually have to add this 12 to the graphing calculators to make it a balanced equation. So that's kind of the tricky part on this one. So I'm adding 5, I'm adding 12. I'm adding 12 to the graphing calculators to get the scientific. So there's 12 more scientific calculators than the graphing calculators. This makes sense because if I add 12 to the graphing, now I have a balanced equation. Then they're equal. And then 28 calculators altogether. Well, that just means if I take my scientific, oh, I said I was going to use X for that, didn't I? So that's my X. So if I take my scientific plus my graphing calculators, I'll get a total of 28 calculators. And that's going to be that's it. I just want to write them that way. We would use probably substitution, which is a different video, to solve this. So you take this stuff and plug it in, but we'll worry about that later. All right, let's go to number 2. I think I have 4 of these made for you. Olivia has twice as many $10 bills as $20 bills in her purse. The value of her money is $120. How many 20s and how many 10s does she have in her purse? So if I have, I'm going to always start with a let statement. Let's let TD be $10 bills. And, I guess 10 and 20 is not, so maybe I'll just use X's and Y's because they're both T's. So let's let X be $10 bills and Y be $20 bills. And then let's go here. So twice as many $10 as 20. So again, if it's confusing, is it 2x equals y or is it 2y equals x? And then my thought was just think of a number again that makes sense to you, that you know the answer to. Twice as many $10 bills. So let's say here's 10s, here's 20s. And if I have, let's say 5 10s, I want there to be, oh, it's got to be the other way around. If there's 5 20s, there's 10 10s. If there's 8 20s, there's 16. So there's twice as many 10s as 20s. So I need to double the 20s to get the 10s. So my 10s are x's, and to double the 20s, which is y's, to get the 10s. Now that makes sense. You might have, if you didn't kind of think that out with these examples, you might have switched those letters around. And then value. Now, how all these money problems work, you have like the number of bills or the number of coins or the number of whatever people. And then the other line is the money or like what it's worth. So the value is $120. Well, I don't just add the number of 10s plus the number of 20s to get the $120, right? If I have 1 10 and 5 20s, it's not just 1 plus 5 to get 120. It's the value of those 1s and those 20s. So I have to multiply that 1 by 10 and those 5 20s by 20 to get the value of them. That's where this 120 comes from. So let's get rid of that mess. Get rid of that mess, because it's too specific, and that's it. That's going to be the system of equations. We don't have to solve those. We would do substitution again, probably. Take this stuff and plug it in for x over there to solve it. Okay, let's go on to number 3. The perimeter of a rectangle is 56. If the length is 4 miles more than twice the width, find the length and the width. Now, earlier we did problems like this, where we draw the picture and we just used one variable. Okay, and if we have like w be the width, and right in the picture, we could say the length is 4 more than twice the width. And then you can figure out the perimeter this way and just add up the 4 sides with a single equation. And that's probably the easiest way to do this problem. This would be 6w7, 8w plus 8 equals, what, 56? But the purpose, if I go back to the beginning, there are directions here, using 2 variables. Okay, so we want to translate this to write a system of equations, just to get practice. So I guess you could draw the same rectangle, but instead of the w here and the formula here, I'm just going to put length. I know the perimeter. Where's the perimeter? The perimeter. The perimeter is twice the width plus twice the length. So I know one of my equations is going to be that. The other equation is going to be how they're related to each other. So length is 4 more than twice the width. That's where this other one comes from. Length is 4 more than twice the width. There's our system. Okay, and again, to solve substitution, we'd plug that in for L. But that's all we had to do right now, is just writing equations from the situation. And the last one, Brenda sold 75 tickets worth this much money for the school play. She charged this much for adults and this much for students. Oh, I forgot my let statement back here, just realized. Kind of an obvious one here, let L equal length. I would have lost points on the test. And W equals width. And then go into that. Okay, just reminded myself, because we have A for adults. Adult tickets. And that's supposed to be a K, isn't it? And what do we have? Students. Let's say, I'm going to put K for kids. Kid tickets. Now right here, 75 tickets. Now they didn't say anything like there's twice as many adult tickets as student tickets, or there's 6 more than 3 times the number of adults. They could have done that, and you'd write that as an equation. Here they just said there's 75 total tickets. So you're just going to have to add the total tickets together. Adults plus kids is 75. It's actually pretty straightforward. There's no other information we have yet. Then the value. There's the money line. There's money, there's money, there's money. Total money is $462.50. And charged $7.50 for each adult. So for every A, there's 7.50 times that. And for every kid, there's 3.50, or just 3.5 times the students. So like if there's 5 adults and 10 kids, you could plug those in and get the value and see if it equals that much. So you could just keep guessing, but it makes a lot more sense to make sure your A's and your K's add up to 75 also. Now here, you could do this, you could use the elimination method to do this, or you can use substitution if you want to rewrite the first equation, probably for A equals or K equals, and then substitute. I think that's all I have for you. Yep, that's all I have. Hope that helps a little bit. If you have any more questions, come on in for help.